In this video, I'm going to talk about how we can use Bluetooth beacons to communicate information back to a central server. Now, typically when we use Bluetooth, we often think of pairing devices, like you'll pair your phone with your car or with your headphones. And in that instance, there might be a lot of devices out there, but once they're paired, they know which ones to communicate. Often there's a master and a slave that are designated internally. This has some limitations in what you can do if you need to communicate with more devices. Another type of topology, network topology, is called a mesh network, which you can also have in Wi-Fi or Bluetooth. And all of the devices are part of the mesh network. And if one of them sends a message, it can propagate and route to another one, or it can send the message to everyone and do flooding. Now, this is an option that we could explore, but the flooding poses potential problems when you have a lot of nodes. Another way that you can use Bluetooth is through beacon. There are two fairly standard beacon protocols. One is called iBeacon from Apple, and one's called Eddystone from Google. And essentially, both of them are types of Bluetooth beacon, but with specific amounts of bytes. In a beacon, one device will transmit a beacon, and other devices will listen. This is usually used in the case where you have some store and there's a device that's sending out a unique ID, and a bunch of devices like phones are listening, and they use that information to load a different website. It's possible that you can have all of these devices being transmitters and listeners when most of the time they're listening, and only when they need to send information out do they transmit. The downside of a beacon is that there's no acknowledgement that the signal that was transmitted was received. But if you know that the devices are close enough and you send your transmission several times, 5, 6, 7, 8, 9, 10 times, then you can pretty much be sure that most of the time your signal will get through. In our particular architecture, in addition to having the beacons transmitting and receiving, we also have one of them or a couple of them that are a bridge back to a server through MQTT. It's a type of protocol that allows for very small packets of information for machine-to-machine communication. And then on that server, we can store the state of all of the different beacons and what they're doing, like being pressed, or if they're activated, or if they're showing something. And then that information can be connected through a WebSocket on a web server, on a laptop, or on a phone. So this demonstration here, we have a server that's running on the left side, a web browser here on the right side, with 3 different input dials for red, green, and blue. And then we have 2 devices here that are set up as beacons. Right now they're set to listening, and when they change, they'll transmit their information as a beacon out, and the other one will listen to it. One of them is connected, the one on the right, is connected to my computer through a serial port, sort of simulating a connection or a bridge through Ethernet, through the internet, to the server. And this one is connected to a USB cable, but this cable is only for power. It's only providing power, and it is not connected to this or to this computer. So this one is all by itself. So on each of these boards, which are identical, they have some LEDs that can be controlled, 3 buttons that in this case represent red, green, and blue, and a Bluetooth transmitter and receiver that's controlled by a microcontroller. So when we press this button, for example here, then this one turns blue. It transmits its signal to this secondary one, which receives it, and it changes its state. And this information is sent through the serial into the computer to the server, and then the web client updates its color. You may be able to see here the blue slider is slightly different. And if I press the blue again, the blue will update on this screen, and again it'll update, and now these are a bit brighter, although it might be difficult to tell. So I can press this again to turn it off, and I can go to the other device here. I can press the red button to turn them red, and maybe a green one as well to make it sort of a yellow color. and another one, and then you can start to see them updating. Another thing we can do is in the web browser, and multiple computers can connect to the web browser, we can modify these sliders, update the color, and that color will be sent to the server, and then through the serial connection and back to this device, which then transmits its beacon signal data out, and the other one listening will receive it and change its color accordingly. So here, if we change this to red and bring these both down there, then both of them change to red. And if we change it to green, or add green, they should be like yellow. And we add blue, it's pretty much white. Remove red, we get blue-green. Add that, change some colors, and so it allows us to change different colors. Here, I'll press another button over here, and I can press a button on this one. And that should give you an idea about how this architecture, this beacon-based architecture, can work with Bluetooth devices, where we can have lots and lots of devices that are listening and a couple that are placed around that link back to a centralized server.